10 lessons in, it's time to stop reading and start copying. Lessons 1 through 10 gave you the parts: stateful filtering, NAT, ordering, persistence. Lesson 11 assembles them into 4 production-grade archetypes: a web server, a Bastion, a Docker host, and a Kubernetes node. Every one of them starts from the same foundation you see at the bottom: default drop, accept established and related, kill invalid. From there, we adapt. Here's the roadmap: 4 archetypes, 4 full rule sets, each one paste-ready, each one paired with the threat model that justifies it. Slide 3 is the web server: public HTTPS, locked-down SSH, rate-limited brute force protection. Slide 4, the Bastion: one door, one job. Slide 5 tackles Docker without fighting the Docker user chain. Slide 6, Kubernetes, where kube-proxy owns the table and you work around it. Adapt the IPs and ports, the structure stays. Recipe 1, the web server: default drop policy, then contract does the heavy lifting. Established and related flow through, invalid gets dropped early. 80 and 443 open to the world via multiport. SSH bound to the office subnet 10.0.5/24 and rate limited to 5 new connections per minute with a burst of 10. Critical detail: the limit applies only to new. Existing sessions never hit the counter, so your own shell stays responsive while attackers crawl. Recipe 2, the Bastion host. Here we flip the script. Output defaults to drop 2, which is unusual but exactly right for a jump host. One way in: SSH from the office subnet, period. Outbound is locked to RFC 199/18 destinations on port 22 and DNS to a single internal resolver. No general internet, no public package mirrors. Updates come from inside. If the Bastion gets popped, the attacker lands in a box that can't even resolve google.com. Recipe 3, the Docker host. And here the cardinal sin is flushing chains. Docker owns Docker, Docker Isolation 1 and 2, and the NAT pre-routing DNAT entries that publish container ports. Touch those and you break networking for every container on the box. What Docker leaves for you is Docker user, which fires before its own Docker chain. That's where you inject blocks, drop bogons from 192.168, allow the Docker zero bridge, whatever your policy demands. Host-level input still works normally for services running on the host itself, and if you ever do flush by accident, systemctl restart Docker rebuilds everything. Last resort, but it works. Recipe 4, the Kubernetes node. And the lesson is even sharper here. Kube-proxy rewrites the NAT table every 30 seconds. Touch it, and you've already lost. Your job lives strictly at the input chain for the node itself. Default drop, accept established, allow SSH from your management subnet, and open 10.250 and 10.256 only to the cluster CIDR. Then explicitly accept traffic from CNI 0 and Kali Plus interfaces so pod-to-pod stays untouched. Filter the node. Let kube-proxy own the cluster. Now step back and look at all 4 recipes side by side. The first 5 lines are essentially identical. Flush, default drop, accept established and related, drop invalid, allow loopback. That's your universal prologue. Allow list, not block list. Reply traffic before anything else. Drop the malformed garbage for free, and never ever block 127.0.1. Memorize these 5 lines. Every production firewall you ever write starts here, then specializes. So why the convergence? 3 reasons. 1. The internet is hostile by default. Your server gets scanned within minutes of going live. So default drop with explicit allow isn't paranoia, it's the baseline. 2, established before everything else because reply traffic always exists, and blocking it breaks every outbound tool you have. 3, specialize at the bottom. The first 5 rules are foundation. Rules 6 and beyond are where the server's actual job shows up. Same skeleton, different muscles. Quick reference before we dive into the archetypes. Keep this one bookmarked. Web and API ports on the left, the usual 80.443 plus the 80.80.8443 Alt SVC pair and the 3000 to 5000 range every Node and Python framework defaults to. Middle column is your infrastructure baseline, SSH, DNS, NTP, Prometheus scraping on 9090, Node Exporter on 9100, WireGuard on UDP 51820. Right column is where people get burned. Never expose Docker's 2375 unauthenticated, lockdown Kubernetes on 10250, and remember the node port range is 30,000 to 32,767. That's a lot of surface if you're not careful. Now stop watching and start typing. 3 drills, about 40 minutes total. First, take the web server recipe and rewrite the SSH source for your actual Office subnet and apply it with a rollback timer, because you will get the subnet wrong the first time. Second, spin up Docker in your VM and just look at the chains it creates. Don't touch them, learn them. Third, build a foundation script with the universal prologue and a rollback trap on ERR. Every new server you provision starts from that file. Before you touch a single production box, internalize these 5. Everyone is a real outage someone shipped. Copy-pasting a recipe with the wrong source subnet and locking the team out of SSH, running iptables-f on a Docker host and wiping the Docker chain, pasting Bastion-grade output drop onto a web server and watching DNS, cert renewal, and package updates die. Forgetting to persist rules and losing everything on the next reboot, and skipping the kernel rate limit because fail2ban will handle it, except fail2ban is reactive, and the kernel limit is preemptive. Recipes are starting points. Adapt, save, layer. That's lesson 11. 4 archetypes: Web, Bastion, Docker, Kubernetes. Each a tested skeleton you can drop onto a box and shape to your environment. But a recipe you haven't verified is just a hope. Lesson 12 closes the loop. The deployment safety chain. How to test a firewall without trusting yourself, and the graduation that ties all 11 lessons together. See you there.